All right, so in this module, we're now going to take what we learned about directions in the hexagonal system and work an example. So here's the example that I have for you. So again, we're going to determine the indices in that 4-index notation um, for the direction that I'm showing you here. And I tried to kind of indicate if it was hard to visualize where that direction was. So take this direction and see if you can determine the 4-index notation. Pause the video and then come back and we will discuss these solutions. Let's go ahead and start with this problem. So we've got a direction in the hexagonal system. So this is the same one that you saw in the slides. And the goal is to determine the indices, and we want to do this in 4-index notation. So our first step is, though, to treat it like it's a 3-index. So I'm going to write my A1, A2, Z, and then I'm going to see what projections I have in each of those. And so with this, we see that the line is touching this kind of corner, or this edge. And so that is exactly opposite to the A2 that you see here. And so there isn't a projection in the A1 direction. It's just A2 in that plane. So this is actually 0A, and then it would be 1 to get to here of A2. And then it goes up, and as it said in the prompt, it's going up 3/4. So 3/4 of the way up. So that would be 3/4 C. All right. So again, we started in 3-index, A1, A2, and Z, and figure out the projections there, and then we're going to convert. So basically right now, we've got the projections here. If we wanted to stop and go ahead and write it in 3-index just to see, we could do that, right? We need to get rid of any integers, or sorry, we need to get to the smallest integers, so that means multiply by 4. And so if we multiply all this by 4, then that would give us 0, 4, and 3. Oh, one thing you might hopefully have spotted here. So I said that this is in the A2 direction. I misspoke there. It's in the negative A2, right? The A2 is actually going back into the page. This is going forward. So I missed the negative there. So sorry about that. All right. So then if we did want to write it in 3-index, it would be 0, 4, bar 4, 3, right? So again, the question wasn't asking for 3-index, but I thought I'd just stop and do it that way. So this is what it would look like in 3-index. And so we have our indices. And so now the next step is going to be to apply those equations and convert, right? So let's start with U. So these are our 3-index. And so I'll put the labels here so that you see that these are the capital versions. And then we want to go to the lowercase, which is U, V, T, W. So U, lowercase, is equal to 1/3 and then 2 times U minus V, and those are the capitals. And then the V is going to be different, but let's just start with this one. So we've got 1/3, and here it doesn't matter whether you use the integers or the fractions, so I'll just use the integers. This is going to be 0 minus V, which is minus 1. So that this part becomes 0, this is plus 1, and so this is going to be plus 1/3. So V is 1/3, and then 2 times V minus U, and so that is 2 times, and then the V, which is minus 1, and then minus 0. And so this is going to be minus 2, this is 0, so this is going to be minus 2/3. All right, and then t is equal to lowercase u, lowercase v. So that's important to realize because the lowercases are the new indices. So we're talking about these here. So that means the 1/3, and then plus that's going to be the other one, which is minus 2/3. So that gives me, we have minus 2/3 plus 1/3, so minus 1/3, and then there's a minus, and so that gives us 1/3. So t equals that, u equals this, this is v, and then w is the same as capital W, and so that's going to be, what do we have, 3. I just wanted to check one thing real quick because I think I might have switched over and used the 1 here. So let me just kind of go over this again. So u and v, in this case, I used 0 and -1, which were these indices. I didn't use these as I said I was, so I apologize. So I only use 0, -1, and so that means that I should actually, in this case, when I'm talking about W, I should use 3/4, just to be consistent with everything. Otherwise, it won't work out. So that gives me the W, lowercase w. All right, so that gives me, just to put it all in one place, 1/3 minus 2/3, 1/3, and 4/3. So again, you're dealing with a lot of fractions here. It looks kind of messy, but again, this is the way that we have to do this. So next thing, we have a lot of fractions here, so we'll actually want to get the smallest possible integers. And so here we have 3 and 4, so we're actually going to have to multiply all this by 12, which is kind of unfortunate, but let's do that. So what do we have here? We're going to have 4. 12 divided by 3. V is 24 divided by 3, so 12, right? So, no, that's 8. My basic math here is failing me. Divided by 3, yeah, so 8. And then that's going to be -8. And then t is, again, 1/3, so that's going to be 4. And then w, here, this is what? We've got 36 divided by 4, so that's 9. All right, so those are my integers, and so that's what I'm going to put in the square bracket. So 4 bar 8, 4, 9. So it's kind of a lot of work to kind of show you all the conversions and so forth, but we get the direction here in 4 index for this direction shown, which is equivalent to this in 3 index if we care to use that. But again, the reason we're using these is because all of this type of direction, if we show multiple in this system, then they would have the form like this. And so that permutation is what we are after in this system. So even though it looks complicated, that's what we need to have for 4 index.